Imagine rushing across the Japanese countryside at astonishing speeds. The wheels of your vehicle do not even touch the ground. In fact, you're floating. This dreamlike experience will soon be a reality thanks to Japan's famous Maglev bullet trains, the fastest train in the world. Japan is already well known for its extensive Shinkansen train system, which has been in operation since 1964 and carries hundreds of millions of passengers each year. But the Maglev will take it to a whole new level. The Edo series prototype has already reached speeds over 600 km/h during tests on the Yamanashi test track, setting a new benchmark for rail travel. When it enters commercial service, the Maglev will cut travel times dramatically, connecting major cities faster than ever before. The development of this technology began in the 1970s, driven by a vision to create a sustainable, ultra-fast mode of transportation. Today, Japan is on the cusp of a new era in high-speed rail, and the world is watching. Did you know that in April 2015, the Japanese Edo series Maglev train set a world record for the fastest manned train, clocking in at 603 kilometers per hour, or 375 miles per hour. That's faster than any commercial train in operation today. The record was set on a test track near Mount Fuji, carrying 49 passengers. The ride was described as comfortable and stable, despite the incredible velocity. This achievement shows just how far magnetic levitation technology has come. For comparison, the Shanghai Maglev, currently the fastest commercial train, reaches 431 km/h. The Japanese Maglev will operate a slightly lower speed of 505 km/h in service. The record demonstrates its potential. The test run was part of a series of trials that have accumulated over 1 million kilometers of testing. The success of these tests has paved the way for the construction of the Chuo Shinkansen line. So how does the Maglev achieve such extreme speeds? The secret is magnetic levitation. The train uses superconducting magnets on board that interact with electromagnetic coils in the guideway track. The track coils are arranged in a figure-8 pattern, creating a magnetic field that both lifts and propels the train. When the train moves slowly, it runs on rubber wheels. But once it reaches about 150 kilometers per hour, the magnetic force lifts it 10 centimeters off the ground, completely eliminating friction. A linear motor then propels the train forward by alternating the magnetic fields. This system also keeps the train perfectly centered, making for an incredibly smooth and safe ride. The technology is so advanced that China is now developing a similar system to compete. The electrodynamic suspension, EDDS, used here is different from the electromagnetic suspension, MS, used in some other Maglevs. EDS provides a larger air gap and inherent stability. The superconducting magnets are cooled by liquid helium to maintain zero electrical resistance, enabling the powerful magnetic fields required. This is the same principle behind Tesla's Hyperloop, which also uses magnetic levitation. The result is a ride that feels like flying, just inches above the track. The Maglev will run on the new Chuo Shinkansen line, connecting Tokyo, Nagoya, and eventually Osaka. The journey from Tokyo to Nagoya, currently over an hour and a half by Shinkansen, will take just 40 minutes. Extending to Osaka will cut travel time to about 67 minutes, less than half the current time. The line will pass through mountainous terrain, requiring many tunnels and bridges. However, the project faces huge challenges. Construction costs are estimated at nearly $100 billion, and the original 2027 opening has been delayed to at least 2034 due to environmental concerns and local opposition, particularly in Shizuoka Prefecture, where issues with groundwater flow have arisen. Despite these hurdles, Japan continues to push forward with testing and development, aiming to revolutionize high-speed travel. The Maglev is not just a train, it's a glimpse into the future of transportation. Once completed, it will not only serve as a vital link between Japan's largest cities, but also as a showcase for Japanese engineering excellence. The line is expected to carry over 100 million passengers annually, providing an eco-friendly alternative to air travel. With its record-breaking speeds and cutting-edge technology, the Maglev promises to redefine what is possible on rails.